So firstly, why do we call the exponents and logs are related? Now, first thing I want to just quickly go through is that you must know the concept of inverse functions. The concept of inverse functions. So when you talk about concept of inverse function, actually, now let's say if I say that if you have got, let's say, y equals to a to the power x here. Now a to the power x, if I find out the inverse of this function, like I'll take a parallel example, like for example, y equals to 3 to the power x. Now when you find out, let's say, the inverse of this function, now for inverse the steps are interchange x with y, and make y the subject of the formula. So when you have interchange x with y and make y the subject, what happens is that I can write down this as x is a to the power y. And obviously this is now, if you have a to the power y is x, I'm writing this here and this here, so I'm doing nothing in this step. So now since if you have a to the power y is x, then y is going to be log x to the base a. So converting from an exponential to logarithmic relation. Now, for example, here it is going to be log of 3 to the base y, and then y is actually log of x to the base 3 when you convert to a logarithmic relation. So log x to the base a here, if you convert to exponential from exponential or logarithmic relation, you get this. So now what's the identity that is really important here? So what I can do is, if I draw a simple, like let's say this is my y-axis. Now the next step is, if I'm drawing my x-axis here, if I draw an exponential function, let's say my function is 3 to the power x. The 3 to the power x function is something like actually here. This is 3 to the power x function here, cuts at 0, 1. And now when you talk about the logarithmic function, since you know that this is inverse function is always reflection in y equals to x line. So if I draw y equals to x line here, now in terms of y equals to x line, actually if you look at the graph now, if I reflect this part graph, so this is how the graph of log function should look like. So this is y equals to log x to the base 3. Now, as per the properties of the inverse function, the x properties become y. So this is going to cut at 1, 0. Now, just quickly talking about the domain and range. So domain of this function that you saw here, domain of the first one, which is the 3 to the power x function, is actually x belongs to real numbers and y is more than 0. And so that's for y equals to 3 to the power x function. Now, if you have for domain, for log function, is actually they interchange. So x is more than 0 and y belongs to real numbers. You can clearly see that's happening out here. So that's what is the prop. That's why we say that they are log y to the power 3, y equals to 3 to the power x, and y equals to log x to the base 3. They are interrelated. And let's take some more examples on how to tackle the log and inverse functions. So here's another example on how do we actually interlink exponential to logarithmic functions. And I'll talk about the domain and range as well. So now first thing what I really want you to do is I want you to understand sketching of the graph. So let's say 3 to the power x plus 5. And if I've got, let's say, y equals to, let's say, log x to the base 5 minus 2. And the third one is y equals to, let's say, log of x to the base 3 plus 2 in bracket. And I've got y equals to 7 to the power x plus 1 and plus 2. So how do I tackle this thing? Like, how do you find out the inverse of these functions and also put them into the graphical, relation? So first thing is that when I'm finding inverse of this function, let's say y equals to 3 to the power x, so you interchange x with y. So 3 to the power y plus 5. And then you make y the subject. So x minus 5 equals to 3 to the power y. And then y is log x minus 5 to the base 3. Now, if you look at the graphical relation out here, if I have got, let's say, this is my original graph, which is 3 to the power x graph. Now, 3 to the power x graph actually is, I'll just erase this part. Okay, so 3 to the power x graph, actually, it is nothing but the original 3 to the power x is here. And if I add 5, means the entire graph has shifted 5 units. So the horizontal asymptote here that you can see is actually 5 units up now. So here the range that you get is, so the domain is x belongs to real numbers, but y is more than 5. So that's the domain of this exponential function. Now, if you're able to sketch this function, what you can do is you can also remember that, okay, this is my y equals to x line, and you know what? You can just reflect this graph in this y equals to x line. So if I reflect this graph here, obviously it is y equals to 5 line. So I will just quickly draw x equals to 5 line as well. So if I draw x equals to 5 line, so when I draw x equals to 5 line, I get this is x equals to 5 here. So when I'm reflecting this, okay, so now inverse is gonna be actually like this, something like here. So you can see that clearly, that the domain is actually becoming the range of the logarithmic function. So here, if I look at the domain for a log function, this is nothing but x minus 5 to the base 3. And so this is nothing but, okay, so you say that, okay, here the domain is x more than 5 and range is y belongs to all real numbers. So as you can see that the function domain and range, they are getting basically interchanged. So that's how you link up these two questions. Now let's take the next example here. So that is nothing but log x minus 5 to the x to the base 5 minus 2. Now when you find the inverse of this function, actually you just interchange x with y and make y the subject. So x plus 2 is equals to log of y to the base 5. So it is y is x plus 5 to the power x plus 2. So when you convert to exponential form, now actually when you sketch this graph, at the exponential graph of this 5 to the power x plus 2, actually is going to be something like this. If you know the transformation, actually if it is original 5 to the power x graph, pull 2 units to the left, then you get this graph 5 to the power x plus 2. And its corresponding log, I mean, if you wish to draw it, it is going to be something like here. And of course you can find out where it's going to cut x-axis. So the domain and range you can easily predict. Domain is x belongs to real, y belongs to more than 0. And here it is, let's say this is 0 comma 1 or 0 comma 25. So this is going to be 25 comma 0. So that's how you find out the relation in this case. Now the third one is log to the base 3x plus 2. So here if you wish to find out the property x plus 2 to the base 3, so this is y actually. So y plus 2 is equals to 3 to the power x, and y equals to 3 to the power x minus 2. So when you draw this graph here, it is 3 to the power x actually is this graph, and if you move the graph 2 units down, so you got new horizontal asymptote. So it is here, it is going to cut here at 2 units down, so it cuts here at negative 1 comma 0. Sorry, 0 comma negative 1 actually. This is 0 comma 1. So this is the graph of the 3 to the power x minus 2 function. And if you wish to draw the inverse graph, so what I'm just going to do is I'm just going to erase this original one. And now I want to draw the inverse function. So you just draw y equals to x line here, and then reflect in y equals to x line. So that is going to be this part, something like here. So what is interesting is that the domain that it is x belongs to real numbers, that is for the exponential function. And the range for this is y more than minus 2. And if you see for original log function, domain is x more than minus 2, and range is y belongs to real numbers. So this is how they are actually related. Now you can try the third question on your own.